What I've got here for you is a couple of questions related to indirect proofs. What I want you to do is read the questions, pause the video, have a crack at them, and then come back and check your work against the answers I'm going to present to you. Here you go. So just two questions, one on proof by contradiction, one on proof by contrapositive. Remember the steps and what I told you each one relates to. Good luck. So the first question was prove by contradiction that if m squared is even, then m is even. So the contradiction for this one that you'd want to look at is that if m squared is even, then m is odd. So for this one, what I'm going to do is I'm going to assume that m is odd, so m is equal to 2k plus 1. Now if this statement were true, I'd be able to do m squared and get an even number. So let's have a look at that. So if m is equal to 2k plus 1, that would imply that m squared is equal to 2k plus 1 all squared. So then the implication from that would be that m squared is equal to 4k squared plus 4k plus 1. What I can then do is take the right hand side and take this little section here and take out a common factor of 2. If I were to do that, I'd get 2 bracket 2k squared plus 2k, and then I'd have plus 1. And now at this stage, if I say let 2k squared plus 2k equal, let's call it the letter A for this one, the implication from that would be that m squared is equal to 2a plus 1. So what that then means is that m squared is odd. However, what the assumption was that if m is odd, so this m equals 2k plus 1, then our m squared would still be even. However, what we've shown is that m is odd gives me an answer of m squared being odd as well. So what we've then done is that's a contradiction. We've not proven the statement that we've assumed is correct at the start, which means that the original statement is true. So what I can say is fine, that means that m squared is even if m is even. So there you go, my original statement of m squared is even, then m is even, is true. We've assumed the contradiction, we've worked it through, and it's been false for that assumption, so the original statement is correct. That's the way we approach a contradiction. Figure out what the contradicting statement is, prove that that statement is false and it doesn't work, so that then the original statement is true. An example here of contrapositive. So I want to prove by contrapositive that if 7 is not a factor of n squared, then 7 is not a factor of n. So the contrapositive of this one, looking at it from a different perspective, is to say that if 7 is a factor of n, then 7 is also a factor of n squared. So that there's a contrapositive statement which we're going to prove is true. So in order for 7 to be a factor of n, what I'm going to do is I'm going to let n equal 7 times k. So what that means is I'm going to have multiples of 7. So because I've got multiples of 7, 7 will be a factor. What I'm then going to do is calculate n squared. So because I've made that assumption there, what I can say is fine, that means that n squared equal to 7k squared is true. So n squared is equal to 49k squared. Now the 49 I know is 7 times 7. So it's going to be 7 times 7k squared. Now in this one, what I'm going to say is I'm going to let a equals 7k. So what that then means is that n squared is equal to 7 times a. So n squared is a multiple of 7, so n is a factor of, 7 is a factor of n squared. So what I've done is taken the contrapositive statement, proven that that contrapositive is true. So that means the contrapositive is true. And because the contrapositive statement is true, the original is also true. So that's how our steps for a proof by contrapositive work. We take the statement, we flip it on its head and look at it from the other perspective, and we prove that other perspective. Because we've assumed the original statement is true, the contrapositive itself is also true. Now notice the subtle difference between them. Proof by contradiction, we change a part of the statement. And changing one little part does not change the overall statement. But contrapositive, because what we do is change the whole statement and look at it from a different perspective, we compensate for one change by changing another part of the statement. And what that does is it makes this new change statement, looking at it from the other perspective, true. So if we were to revert back to the original, that is also true. So just watch for that subtle difference between the contradiction and the contrapositive. We have to bear it in mind when we're asked for a set technique or a set methodology to prove something, and that's how we'd work it in terms of indirect proofs.